Why, hello there. If you've ever wanted to insert all of the options data from the market into your database from Postgres, well, you can do it automatically now by using a package that I've made called, you guessed it, Footstep. But yeah, seriously, I mean, it's all automatic. I'm gonna show you how to do it in this video. All you need is a key from Polygon. They have a free tier. I believe it's like 5 to 15 API calls a day, but you can still use the script with that key. They also have paid services as well that allow for unlimited API calls, which if you want to go that route, I would highly recommend using the code FUDSTOP in all caps at checkout because you do get a discount on those services because, again, I work very closely with Polygon. They offer an amazing service, and that's what we're going to be demonstrating with in this video here. All you will need on your end is a Postgres database setup. You'll have to have Postgres set up on your computer. This specifically is for async PG. It's integrated with async PG. As far as my knowledge, it's only compatible with Postgres. But if I'm wrong there, then that's awesome. So as far as I know, Postgres is what you're going to want. And other than that, just the FUDSTOP package. You want to pip install it. And I would highly recommend getting a new environment for this because it is a rather large package. No pun intended. But yeah, we're going to just do a few minutes of demonstration here to show you how this all works. Essentially, what's going to happen is we're going to get all of the options data for every ticker in the market that we can, and we're going to automatically create the database table that we need, the correct data types, and then we're going to automatically insert it in batches to the data frame, all in one simple function with just a few lines of code. And all you're going to need on your end, again, is Postgres and a .env environment variable named your underscore polygon underscore key, and then set as equal to whatever your key is for Polygon. And if you need to go get a key, it's polygon.io. Again, for the paid tier, use the code FUDSTOP at checkout. You save money. So anyways, let's go ahead and get started here. So we're going to do from FUDSTOP.apis.polygon .polygon database import Polygon database from FUDSTOP.apis.polygon options import Polygon options. Obviously, we're going to do a syncio. You don't need to actually import any kind of key. Again, all you have to do is store it in that environment variable or as that environment variable, and you'll be good to go. So all we're going to do here basically is just define a main function and async def main, and then we're going to do, well, first let's initialize our two classes here. So the arguments you're going to have to pass in to these classes is going to be your database configuration settings, which for Postgres, it's going to be, you're going to want to make a dictionary, at least that's what I like to do. You're going to do hosts, which localhost, these are the generalized default settings. If you're hosting on a website or something like that, you'll obviously need to change it based on your port forwarding and all that stuff. But the default is just host. Your database, which in my case it's markets. User is Chuck. Password FUD, and then our port is going to be 5432. And this is what may differ, but this is basically going to be it. From 90% of the use cases. So now we can just easily initialize the two classes and say db equals Polygon database, and then just pass in the db config. Let's do db config, not df. That'll be confusing later. And then we'll do the same thing for the options class. So options equals Polygon options, and then db config. Okay, so now what we're going to do is we're just going to test this out. We're going to do run main, and we're going to just do one simple script. We're going to say data equals await options dot get options chain all. We're going to do, let's just do Apple, the most generic thing to do. And if we wanted to, you could also pass in a strike price or less than or greater than. You can narrow down your whatever you're looking for, but if you want to just do the whole market, then you just leave in the ticker right there. So we're just going to go ahead and just make sure this works. And everything, by the way, in this library is notated. So whenever you define something, it's all asynchronous. You're going to want to await all of the functions. Data, data dot, and you get all your attributes here, and there is quite a bit of engineered attributes on top of what Polygon already offers. So if you see something here in this video that isn't offered on the Polygon website, it's not because I'm trying to scam you and I have some secret package. It's just I've spent some time with machine learning and I've engineered my own data metrics on top of what Polygon already offers. So that's why you see things like velocity and options profit potential and delta theta ratio, things like that. It's just extra metrics that I've added on that are helpful in my day-to-day routine. So anyway, we're just going to go ahead and just print the data frame, which is an option, and we'll just see what we get back just to ensure that it's going to work from the get-go. Okay, and it did get all the options. Perfect. So we have the earliest expiry obviously being tomorrow, and then we have the latest being 2026, 06/18, and we got a total of 2,354 options, which should align with what you see in your options chain. And the reason why you see these zeros down here and these NaN values down here, and why there's such a big difference, is because that's the effects of time with options. As you get closer to expiry, these things like your Greek balances are going to be much more relevant than way further down here when they're going to be negligible because there's so much time left on the clock. So that's a lot of the reason why you see that. But there is a vast amount of data that's being captured just by that one ticker alone, Apple. So now that we know that works, now what we're going to do is we simply just connect to the database using await db.connect. Very simple. And now we're connected. And now we can erase this and we can pass in a ticker now, right? And we can essentially erase this. We don't even need to do any of this. We just do this and this. And what we can do now is we can say async def run main, and we can say this. First, we're going to need a ticker list. And to get that, what we can do is we're going to do from fudstop.apis.underscore markets.listsets.dictionaries, and we're going to import all of the different sector categories. So we're going to do, what are they? ETFs, energy, real estate, financial services, healthcare, technology, utilities, industrials, basic materials, communication, consumer cyclical, consumer defensive. I think that's all of them. So now we have that, and then I've already gone to liberty of having GPT add these together for us, except it kind of did it a little bit retarded. We just got to find and replace right here. There we go. Now we have a list of all of the tickers, and essentially what we can do is do one more import here and do from fudstop.apis.helpers import identify sector, and we can actually engineer, and this I'm showing you how you do data engineering, because as of right now the sector doesn't exist in the category or the data that Polygon provides. So to add in the sector, we simply just have a preset list of tickers that I've already organized into their correct sector that we can easily pull from with the function. So now we can just simply define data frame as await options.getOptionChainAll. Actually, let's just define this as data, not to be confusing. Then we'll zoom in a little bit more. Then we'll do data frame equals data.dataframe, and then we'll say data frame sector equals, we're gonna have to get the sector first, so one moment, sector equals await identify sector, and then pass in a ticker, and then sector equals sector. So that will add in the sector to the data frame. And then from here, we're almost done. All we do now is we say await db.batch insert data frame, and all you need to pass in here is the data frame itself. Give it a name, and to show you this works, I'm going to go to my Postgres terminal here. Go to the markets database, and I'm going to go ahead and we're going to do drop table test options, and then drop table test options history. So we've dropped those tables. So I want to show you, I'm going to zoom in and show you that if I do this, if I do select anything from test options, it says test options does not exist, but we're about to automatically create it. So let's go and do that now. Table name, again, let's just give it a name. Let's do a completely different name for this example. Let's just do T key. Why not? That way you know it's a new table. We're going to give it a unique column, meaning whenever this column is we're going to make it the option symbol, obviously. So basically what this means is that any time that the option symbol passes through in the future, it's going to automatically take the data that currently exists in the database and move it to the history table that's automatically created when we start this function. And it will constantly keep the most up-to-date information in the main table and will move the changed data to the history table. And if I show you the database that I have, that's why you see all these tables here with all these histories here, because it's all automatic. You get your main table, then the history table. Your main table, and the history table. That way you can keep track of data and the changes over time, which is highly beneficial for market data. So this is basically the script, except instead of doing one ticker, we're just going to add some concurrency because it's, Python. Tasks equals, we're going to do main I for I in all tickers, and then await asyncio.gather tasks, and we're just going to run main, and that's just all we need. I mean, we're talking less the imports. We're not talking about imports and initializations. It's not much code at all to get this done. Not much at all. Two very, very small functions. So let's go ahead and run this and see what it does. The first thing we should see in the output is a bunch of tickers come down the list, or the table being created, one of the two. Let's see if Teehee. Yeah, Teehee does not exist yet. Oh, whoops, I forgot to connect to the database. We need to put this not in the main function. That just overloaded the shit out of the Postgres system. So we need to put this down here. That way we only connect once. My bad. Now it should work, buddy. We should see the created tables come into play here in the screen after it's done processing them. I believe it's 4,000 something tickers that it's going to be processing. So it's going to take just a minute, but I mean, that's essentially how it works. It's going to take each ticker, automatically create the table it needs to create based on the data that's in the columns, identify the correct D types, and then insert it properly into the database. Then you can easily query it from there. So let's give it a minute here to get going. Again, a lot of tickers here. I should have probably showed you how it works on one ticker before I did everything, but that's the point of this video, is to show you that it will indeed work on everything. It's going to have to get through all those tasks though before it can even make the table. So there you go, right there, connected to the database. And there it goes, made the table right there. So let's see, it said create table Teehee. Got all your columns there, all nice and lowercase with underscores, changed properly. Table Teehee created successfully, perfect. Now what it should do is it should create the history table, which is going to, again, automatically move any data that's, if the option symbol passes through again, like if I run Apple today and I run Apple tomorrow, it's going to show me the difference between the data as it was captured tomorrow and, wow, I got an error. What was that? 2024 223 must be a real number, not string. Spoke too soon. I spoke too freaking soon. That's never happened before. So hold on a second. What did it do here? Oh, it's got the DTE wrong. It's got the DTE wrong, laddie. I think I may have just added that one in, lad. No, it's a date. It's a date. It's got to be the date column. Yeah, it's expiry. It says expiry is double precision. Oh, God. That normally doesn't happen. So let's do this. Hold on. Just to show you. It probably picked a weird ticker to start with, which is why that happened. So let's do this. Let's just go ahead and comment this out for now. We're just going to do asyncio.run main. We're going to pass in Apple. And we're going to drop this teehee table. And we're going to drop teehee. I don't think it made a history table. No. Oh, it did. Okay. All right. And we're going to run this and just get that first ticker in. Oh, what's the problem now? Oh, I didn't connect to the database. Don't do drugs, kids. Silly mistakes. Okay, so we created the tables. We got two tables created this time. We got table teehee, again, created with the expiry text. Perfect. Okay, it did the right column this time. I need to investigate why it decided to arbitrarily make the expiry column a double precision. That's why it messed up. But this looks like it was correct. So now we can confirm this by going to our database and saying select ticker strike expiry, or CP, sorry, expiry, CP is for call put, from teehee. And there you go. That's it. You have the entire Apple options chain. If we wanted to do it by date, order by expiry descending, that's the latest expiry to today. And we wanted to do the opposite, and boom, there you go. And you can do, obviously by strike price, whatever you wanted to do. Volume even, you name it. Volume in this database is VOL. There you go. That's your volume in order. If you wanted to see the volume, obviously you just add on volume to the query. There you go. That's lowest to highest. If you wanted to do highest to lowest, there you go. It's as simple as that. Of course, everybody trades the near-term expiry, but it is what it is. But yeah, very, very simple stuff. That's just one ticker, though. This video is about the whole market. That's just one ticker. Now that we have the database correctly initialized, we can go ahead and do that again. So let's go ahead and try that again. Unexpected connection error. I swear, I better not give me any trouble, man. So as of right now, if we go and we count, select. Ooh, yeah, my computer's getting slow on me. That's what I like to feel. Select count from teehee. We have 2354 as of right now. God dang it. I forgot to move the connection outside again. My bad. No, whoops, I have to actually connecting twice. So yeah, definitely if you're going to do the concurrent all at once shit, definitely don't leave the connection up here in the main function because it will not work. You only want to have it down here so it'll only connect once and not overload everything. Just going to give it a second to do its thing. But yeah, I mean, 2354 right now, and that should go up substantially here in a minute. Once it front loads all 4,000 whatever tickers. Let's just see real quick. I'm going to rerun this, comment that out while this other script is running. We're going to do print length of all tickers, just so you can get an idea of what we're dealing with here. Yeah, okay, so we're dealing with 4,450 tickers here in this all tickers list, confirmed to all have options. Because what I did is I made sure that when I was querying them in the screener, that I made sure that IV was set to 0, because if it has IV, it's got to be an option. So that's essentially the logic behind it. So let's go and check our database again. Still at 2354. It's going to take a second because again, it's 4450 tickers. You could definitely use a much smaller sample size of tickers, and it would be done, way quicker than trying to do the whole market at once. But I'm just trying to show you that the whole market at once is a possibility if you so choose. Oh, hey, look, it's starting to increase. 2754. It's going to keep going. 2966. 3176, and it'll pick up. 3556, 4304, 47. It starts getting exponentially faster as it catches up, and eventually, you can't keep up with it. It just, as fast as you can refresh it, and we'll end up with somewhere in the ballpark of maybe 1.5 million records at the end of this, and it takes about, I would say, in totality, depending on your operating system. This is all from my OS, so I mean, depending on your system, I mean, you can take anywhere from a few minutes to maybe max 15 to 30. It just all depends, but yeah, it's going. And then you can just query from here, like whatever you want to do. Select what do you want to know. You want to know the volume. Select. Obviously, I like to do ticker, strike, CP, expiry, because you get to see which options meet which conditions. Like, if you want to throw in some volume in OI, you can do that. Where, volume is greater than OI. And let's do, and theta is, we don't want to bleed more than, we want to do greater than or equal to negative 0. I like staying up, I don't like going any lower than this. Oh, what? Oh, what? Didn't even pick the right table. From Teehee. You can name your table whatever you want. And there you go. Now we have a custom list of what we wanted to see. So like ticker, strike, call put, expiry, volume, OI from Teehee, where volume is greater than OI and theta is greater than or equal to negative 0.04. And that's just one example. You could get way more specific. And I believe it's automatically going to index it based on the ticker name, which is why you see Apple here at the front. And then it goes, no, maybe not. Wow. But yeah, I mean, these are all the tickers that meet that criteria. And then you can just narrow it down from there. And this is where LLMs come in handy, man, because, I mean, SQL is essentially just English. So if you can get all this into the database and then just start talking to this LLM, it'll do some nice queries for you based on what you ask it. But yeah, whatever you can think of, basically. Let's do select everything we want. Let's just do this. And order by. Oh, hold on. Because it's going to be SPY, obviously. Where ticker. I'm missing a piece here again. From Teehee, where ticker is not equal to SPY. And let's do that. Order by volume descending. There you go. And then, if you wanted to see the volume on top of that, you just add in volume, and then you get the volume metric. So you can actually see the volume amount. So, again, it's just whatever you can think of. Select, ticker, strike, call put, expiry, from, where, let's just do order by velocity, descending. And there you go, there's your velocity. Your highest velocity to your lowest velocity. They're all calls, go figure. Jeez, man, I wonder what are the velocity values? I think I might have that backwards. No, it's there. Okay, wow. Damn. Insane. AMC's right there at 27.76. But yeah, I mean, where are we at now? Let's just check the records again. Let's check the count. Yeah, I mean, look, we're over 1 million. It's been like, what, 30 minutes went by? We had, the last time we checked, it was at, forgive me for scrolling up, but I gotta know. It was 97,000. So it increased tenfold in about just a few minutes flat. We're at 1.05 million, 1.18 million, but you get the point. Shit's crazy. Have a field day with it, kids. But no, for real. Let me know if this helps anybody, because I'm bored as shit. That's the only reason why I made this video. But this is what I basically deal with on a day-to-day basis. Is trying to efficiency, or focus and enhance the efficiency of programs to do cool shit like this, where you can now work with this sea of data that is just very, very powerful. If you are one of those people that likes to work with this kind of stuff, just something that's fun to do. Anyways, hope this helps somebody.